1. I'm going to take a group of 3 times 3 and square it. Now with this, I would say that, well, 3 times 3, is actually very similar to 3 squared. And well, I'm squaring it. So that's the same as saying 3 squared, because squared means that you take something and you multiply it by itself twice, times 3 squared. But we all know that, of course, that's 9, and times 9 is 81. Perfect. Okay, let's go on to example 2. In this example, I have 2 cubed, and I'm going to square that. So, of course, I'm going to take what's in the parentheses, 2 cubed, and I'm going to multiply it by itself twice. Now, this sounds very similar to what we just finished talking about, our product rule. And our product rule says that if we have the same base, we can simply add our exponents. So, to the 6th power. Now, a lot of you guys already told me, well, I know that's 8, and that's 8. So my final answer is 64. Now, this one's really important. Okay, we're going to come back to that. Example 3. I have a squared, and I'm going to raise it to the 6th power. So here, let's go ahead and do, well, the same thing here. A squared, I'm going to have it 6 times. Goodness, that's a lot. So according to my product rule, I would say 2, 4, 6, 8, 10. That's a to the 12th power. Awesome. Example 4. I have 4 squared raised to the b power. Oh, well, this is kind of strange. Well, we were noticing something here. And, well, that one's actually kind of quite simple because of the fact that, well, whatever I have on the inside here, that's going to give me 16. And then I have this b on the outside, so my final answer would be 16 to the power of b. Well, let's try something a little different. Let's do the opposite. Example 5. What if I gave you 4 to the power of a, and I want to cube that? Interesting. Here I would probably do what we were doing up above on 2 and 3, and I would take what I have on the inside and multiply it by itself 1, 2, 3 times. Now here I have the same base, and I'm going to add those 3 a's. Now, technically, this 3 and that a, they're being multiplied. Well, couldn't I simply, and a lot of you guys were saying that, okay, well, I have this 4, kind of like I had up here, technically we would have been multiplying all of those out. That 4 is being raised to the 3rd power, and that would give us 64a. Oh, interesting. Okay, let's go ahead and continue with example 6. A to the power of m raised to the n power. Now, if we take a look, what we had done to a lot of these was we simply took our 2 exponents and we multiplied them to get our final answer, as long as they had the same base. So let's go ahead and write that out. That should be a to the power of m times n, or you could simply say a to the power of mn, whichever one floats your boat. Now, keeping that in mind, let's try our last example. example 7, I'm going to give you a group of 3a squared raised to the power of 3. Now, of course, I can go ahead and take this inside and times it by itself 3 times. So 3a squared, 3a squared, and 3a squared. Now, what happens here is I'm going to break this apart a little bit more. That's going to be 3 times a squared. And just like we had done before, I would take apart my coefficients and rewrite that. That would be 3 cubed times, now I can kind of use what we've been doing up here, a to the power of 2 times 3. Okay, well then, of course,